This is lesson 5.2, solving systems of linear equations. But this time, instead of graphing like we did in our previous lesson, we're going to be doing this by substitution. And substitution is when you're going to replace one variable with an equivalent expression. It could be a numeric, or it could be just another expression with other variables in it. So we're going to start off with some very basic ones where here we have two equations. And the second equation, we have a value for x. So all we're going to do is we're simply going to substitute in that value for x and solve for y. So when we substitute in, always remember to use parentheses. Every time you do substitution, please use parentheses around the entire part that you're going to replace. So I replaced the x with 9, and now I'm going to do 2 times 9, which is 18 plus 7. 18 plus 7 is 25. And so we have the solution, which is when x is 9, y is 20. We write that as an ordered pair, 9-25, or 9, comma 25, like that. For this next problem, we're going to replace x with -3. So once again, I'm going to use parentheses. So there I have my parentheses in there. I'm going to do 4 times -3, which is -12. That's going to give me -17 for y. And so my solution is when x is -3, y is -17. Again, we write it as an ordered pair. Now this last one on this page, I don't have a value for x like I did in problems 1 and 2. But I do have an expression. I have that 2x plus 1 is equal to y. And I have that x plus 6 is equal to y. Since they both equal y, they equal each other. That 2x plus 1 is going to equal x plus 6. And you can think of it that we're doing substitution of this expression for y. That's saying that they're both going to be equivalent. To solve that, we subtract x from both sides. We subtract 1 from both sides. We get that x equals 5. But that's only one of the variables. We have x and y. So here we see, I can pick either one of these two equations. It makes no difference which one. I'm going to pick the top one, that y equals x plus 6, because it's a little bit, it just seemed easier to substitute in. So now we're going to put that 5 into this equation. And we get y equals 5 plus 6, which is 11. So my answer is that when x is 5, y is 11. And so we answer it in the ordered pair. Now we're going to start getting a little bit harder problems. This one's still the same idea in that we've got this equation where they both equal y, so we can set the both of them equal to each other. And since they equal each other, I can set them up that way. Subtract x from both sides, subtract 4 from both sides. 2x equals -2. Divide by 2, I've got x equals -1. But again, I have to solve for x and y. So I'm going to take this -1, plugging it into either one of these two equations. Doesn't make any difference. I picked, again, the top one. It just seemed easier. So I plug in that -1, evaluate it, and we say, oh, when x is -1, y is 1, and so we have our ordered pair. But you might be saying, well, did we have to plug it into y equals x plus 2? No. We could have just as easily plugged it into this x value. We could have plugged it into the other equation, 3x plus 4. So let's just do that, just to see what happens. I'm going to plug in the -1 there. I get 3 times -1 plus 4, which is -3 plus 4, which is 1. Well, they're both 1. It didn't make any difference which one of these two equations I used for my substitution after I solved for the first variable. The end answer is -1, 1. I got this other problem, number 5. These are from your checkup. So here you can see that they both equal y. So you would just set them equal to each other. 3x plus 11 is going to be equal to 6x plus 2 and solve. And you're going to do that one for your homework. This one here, let's do this one together, because now all of a sudden I don't have them both equaling y. They both have both variables in each equation. So I pick one. I just picked the one on top, and I just felt like it was going to be easier. It doesn't make any difference which one. But you pick one of the equations and you're going to solve for a variable. We're going to solve for y. And to solve for y, I'm going to add 5x to both sides. Well, that's going to give me y equals 5x plus 7. And this now is a substitution because I have solved for one of the variables. So wherever I see y, I can replace it with 5x plus 7. So I'm going to look at that second equation. 3x, so up here was 3x minus y equals 9. So I've written it down here, and where I see y, I'm going to substitute in 5x plus 7 with parentheses. And this is why it's crucial, because outside of the parentheses is a negative. And we need to distribute that negative, which gives us 3x minus 5x minus 7 equals 9. We're going to collect like terms, so our 3x and our negative 5x. We're going to add 7 to both sides, and we get negative 2x equals 16. Dividing by negative 2, remember this was a negative here, so you're going to divide by negative 2 to get rid of the whole coefficient, and you end up with x equals negative 8. Well, what do we do with that? We're going to plug it back into this equation that says, oh, I know what y is. Y is 5 times x, which I've solved for, plus 7. So we put 5 times our negative x, our negative 8, which is our x, plus 7. Well, 5 times negative 8 is negative 40. Negative 40 plus 7 is negative 33. So I have my x, I have my y. We write our ordered pair. So again, this problem was I had to solve one of the equations for a variable. So I picked the top one and I solved it for y. Then I used that in the other equation to solve for x. So there's several substitutions that happen. All right. In this problem, similar to the other one, we don't have a variable solved for it. We almost do. This one here has a negative x, but I need to solve for just x. So I'm going to take that equation, and I'm going to divide everything in that equation by negative 1. And by doing that, it's going to change this negative x into a positive x. So now we have solved for x. We're going to take this substitution for x, negative y plus 9, and we're going to substitute it back into the other equation. You can't plug it back into the same one you used because that everything will just cancel out and you'll always get 0 equals 0. And that didn't help us. So you use one of the equations to plug into the other equation. So here we've got that x. We're going to plug in for that x, negative y plus 9, using parentheses. Now here, remember it says negative 2x. So it's a negative 2 outside the parentheses. We're going to be distributing all of this, not just 2, but negative 2. And so when you distribute negative 2 times negative y, you're going to get positive 2y. So this was the distribution. And when you have a negative 2 times a positive 9, you get negative 18. I'm now going to collect my y's, get 3y minus 18. I'm going to add 18 to both sides, get 3y equals 21, and divide by 3 to get our final part of the first part. So it's the final part of solving for one variable, which is y equals 7. See, all right, but I need both the x and the y. So I'm going to take this y equals 7, and I'm going to go back up here where I had my x. And that's where I'm going to substitute back in this 7 to solve for my x. So x equals negative, and then I substituted in 7 plus 9, which is negative 7 plus 9, which is 2. So I now know that the solution to this system, what makes both of these equations true, is when x equals 2 and y equals 7. And we know from our previous lesson, every time I've been solving, this would be the point of intersection if we were to have graphed the lines. Here is another problem, and this one's even trickier. Because if you look at the top equation, there's parentheses here. We need to simplify our equations as much as possible before we begin this process. So we're going to do some distribution. I'm going to be distributing the 4 in this first group, and I'm going to be distributing the 8 on the side on the right-hand side. And when I distribute the 4, I get 4x minus 8. When I distribute the 8, I get 8y minus 8. I'm going to add 8 to both sides. Since I see that it's on both sides, it's negative 8. By adding 8, that's going to make it just easier. I have 4x equals 8y. Now I'm going to solve for one of the variables. I'm going to solve for x because I can divide both sides by 4. And when I do that, I get x equals 2y. If I tried to solve for the y, I would have ended up with a fraction, which is okay. But you get to choose whichever way you like, and I want to keep fractions out of it if I can. I'm going to substitute that 2y into the equation I have not yet touched, which is the second equation. So where I see x right here, I'm going to plug in a 2y. So here I'm going to rewrite the equation. 16y minus 32 equals 2 times what was x, now it's 2y, plus 4. I'm going to simplify by multiplying these together. It's distribution. And now I'm going to get all my y's on one side, on the left side, and I'm going to put all my numbers on the other side. So I need to subtract the 4y, and I need to add the 32 to both sides of the equation. When I do that, I end up with 12y equals 36. Dividing by 12, we get y equals 3. And we're not done. It's like, oh, haven't we done enough? No, we've solved for one variable. Remember, we have to solve for both variables. So once I know what y is, I can bring it right over here to this to solve for x. So x is going to equal 2 times that y, which means x is going to be 6. And therefore, these two lines, these are equations of two lines, they intersect at the point 6, 3. And this is also called the solution to the system because it's what makes both equations true. Now we're going to do one application. On this problem, we're talking about distance and rate. I want you to remember that rate is equivalent to slope. That's what rate is. Rate of change is slope. And Lauren, who's riding her bike, she's starting at the starting line of this race. And therefore, she's starting at mile 0, which means that's her y-intercept. Where you start is your y-intercept. So her rate is 18 miles an hour and her y-intercept is 0. Now Minky, she has a rate of 12 miles per hour, and not only that, she gets to start at mile 6, which means her y-intercept is going to be 6 because she has a head start on Lauren. We're going to be writing the equation of distance, and it's always distance from the starting line. So remember, Minky's distance from starting line at the very beginning is 6, but Lauren's is 0. So Lauren's distance equation is distance equals her rate times time plus her start amount, which was 0. She didn't get any extra starting amount. But for Minky, hers is D equals 12t, her rate, plus the 6 miles of start that she got. Because she got to start 6 miles ahead of the starting line. So solving the linear equation, meaning when does Lauren catch up with Minky, is asking when will they be the same distance from the starting line? Since they both equal the same D, which stands for distance from starting line, I can just set their two equations equal to each other. They're two expressions, I should say. They're equivalent expressions. We're going to solve by subtracting 12t from both sides. Divide by 6, and we get that t equals 1. We need to finish this up by writing what that means in the context of this problem and the question that was being asked. So when does Lauren catch up with Minky? In 1 hour, Lauren and Minky will both be 18 miles from the start. So this is when they catch up with each other. You could have also phrased it that in 1 hour, Lauren will catch up with Minky. Either way, by saying they'll both be at the 18-mile mark means they've caught up.